Hi, Emanuele. Hello, Angelos. Good morning. Good morning, everyone. Hello, everyone. Can you hear me?
Good morning. Yes.
Wait, let me choose my virtual background, which I forgot to add. You could actually see my house. So I think we have Giovanni here and we have Emanuele here. So I think we're ready to start. So I see some of the students are mostly here, and myself and Theodore are going to be coming in and out of the meeting because we have a parallel session, which is a little bit tricky. But yeah, so first of all, let me thank, let me switch this to here so I can see you and you can see me. So let me thank everyone for working really, really hard this week to produce results. Let me thank Narid and Yosa for a lot of effort last week before we even start this workshop, and a lot of effort this week to help the students produce the results. So big kudos, because we've got finally the InFraReD Grasshopper integration. Giovanni already hates me for that, because we were supposed to have that ready for his class in Berkeley, but we didn't. It sounds like we were waiting for our own class, but it's not the truth. We did tries. But in any case, thank you to all. I want to introduce first of all Giovanni Betti, professor at Berkeley, and Emanuele Naboni, professor at Malta, University of Malta, and the Royal Danish School of Architecture, right? Am I correct in that? So, and we have a bunch of like really hardworking professionals and students at the same time, so they've been working all week and also sort of like fiddle with our like messy code. No offense, Nari. And we want you to like have a look at their projects and tell us what you think. And we're actually live on YouTube. I just want to say that. And now the meeting is recorded as well. This horrible sort of like notification, but yeah, I want to say this is like it's a short experiment, but it's also sort of like for us a very interesting point of time where we see how InFraReD is actually used by people. And you know, they are these people are like our guinea pigs, or are like fantastic sort of like pilot customers. So I'm not going to talk anymore. I've talked enough. I will let Narid coordinate. So Narid, if you want to share a couple of words, and then we start with the first project.
Absolutely. Well, I think a big thanks goes to first like the participants. You guys have gone through a lot over the last week. I've been with you guys. I've seen what you've been able to produce in just a week's time. I'm super keen to see it presented in this final presentation. And regardless of the outcome, you guys have done an immense amount of work, and I'm appreciative. You know, thank you all for putting in the effort. Would you like to share a few words as well, Josh? Or?
Nothing. much more to add. I'm excited to see the results.
Yeah.
Let's start.
Alrighty, so you guys have a total of, we've given you 5 minutes, but we're stretching it to 7 minutes just for a little bit of flexibility and whatnot, and a little bit of a Zoom finaffling. And then afterwards, we'll have, again, another 7 minutes for our panelists to provide a little bit of feedback. Good. So let's get started. Group 1, you guys ready?
Yep.
Feel free to share screen, feel free to get right into it.
Can you see the presentation?
We can, yeah.
Perfect. Yes, first of all, I would like to thank you guys for this amazing workshop. We've been learning a lot, and it's a privilege to be able to test the tools firsthand. So let's start. So we are group 1, and we've chosen the site of Barcelona to test and to develop this project. So the idea is that, okay, this area was part of a old competition called Open, as we are aware of. So the main objectives were to create a connection with the existing urban fabric. We know Barcelona is very rich when it comes to that. This urban connections with this old urban fabric tissue. Refurbish the area in order to create new housing, office, and cultural spaces, and of course, give priority to open spaces, parks, and create this connection and integration between the functions, so the city or the area becomes very lively. So we run just a few climate analysis, and as you can see here on the left, the wind rose indicates that the prevailing winds come from north. If we look at the radiation rose in the middle, we see that heat gains go up to 1,000 kilowatt per square meter. The majority comes from the south. And then looking at the psychometric chart, we notice that we have a lot of hours, usually over 100 hours, that we're out of the comfort zone. So we need to take interventions and measures to be able to tackle that in our urban studies. So starting with the vision, the idea was to develop something that was very populated and safe, bring on the diversity of activities to make it a very attractive area, and in order also to be able to activate daily life, and of course, develop all this vision through a sustainable development with a sustainable vision. In order to achieve that, we developed a couple of strategies. So using mixed-use typologies, make the area very walkable, and in order to do so, we need to make sure that it is also comfortable with a lot of greenery and shaded areas. We know Barcelona is pretty hot in the summer, and of course, trying to tackle the problem with high energy consumption. The KPIs we have chosen and we came up with were solar radiation on ground, solar radiation on facades, wind speed and wind comfort. And when it comes to quality spaces, we have chosen compactness, occlusivity, and also PV potential. So the whole idea for the area is that we could develop all these mixed use, let's say, typologies, and mainly trying to connect the existing urban tissue. We know it's an industrial area, so but some of the buildings around might have some cultural value, so why not keeping them and keeping this spirit of the place. And what we see on the right is that the idea we used, like inspired by the super blocks from the old urban fabric in Barcelona. So there's buildings that take the perimeter, but they leave a courtyard in the middle to create this microclimate, but rather in a very optimized version, which is the plans are less deep, so 12 meters instead of 27, which is what we have in the old urban fabric of Barcelona. So it gives more access to daylight and also creates a better microclimate. And of course, we can see on the lower right that we can variate this typology as much as we want to create the well, the uses that we want. They can be offices, housing, and cultural spaces as well. We came up with 5 different proposals, and I think as Theodore said, the main aim was not actually to pick the best proposal, but rather compare these proposals and see how we can interact with the tools and what answers they can give to us in order so we can actually compare them and see the pros and cons of each one of the proposals. And basically, so we vary these quarters or these blocks around these 5 different proposals. Some of them, they have some towers as the highlight spot of the area, and try to maximize the green spaces and the green areas as much as possible. As for the visibility analysis, we chosen 2 metrics, compactness and occlusivity. And it's very interesting to see, of course, that the 2 first proposals here on the top, they have a lower number, which means they're more complex, which I think is something interesting, is the feeling that we have a surprise when we visit like old European cities. So that might be something interesting to recreate. And I think this metric tells us a little bit what or how diverse or how complex is this environment or this new place that we're creating. And then when it comes to occlusivity, we see that the 2 last proposals here on proposal 4 and proposal 5, they have more open spaces. Therefore, like it's pretty low, the occlusivity. So the whole space, the visibility is a little bit enlarged from the main interested points that we came up on this urban planning proposals. And well, I think I'll hand over to Saket. He's gonna talk about the environmental analysis.
Thanks, Diego. So I'll continue from here on the different analysis we did. And as Diego mentioned, we were not trying to come up with the best solution, but more to test out different tools from different plugins and integrate them in with InFraReD, see what's possible and how we can just play around with different things and improve the workflows that we typically have, basically. So let's say we are using InFraReD to do the solar insolation analysis, and a few common things that we can observe is that some massings create more insolation in the courtyard areas or in between the massings. These could be good spaces to put up parks, or the inferences could be that if these spaces have to be utilized for outdoor sitting or for conducting long hours activities, then they need to be well shaded. And the speed of the simulation allows us to test out multiple options. So that was one great thing. Since we had only 2 days, we just tried to narrow down to only 5 options, but just try various types of analysis. Something more interesting, maybe we could look at the performance of the options in terms of KPIs. So let's say how much is percentage area that's below a certain threshold, and we could filter out the performance of those options based on those numbers as well. We could actually, if we had more time, we would have wanted to split up the analysis between summer and winters, or maybe the 4 seasons, because in summers we want to reduce the isolation and insulation, and then in winters we want to maximize it. So that would be perhaps the next level of breaking up these analysis. For the wind, we chose just one wind direction, which is the north, the most prevailing wind, with the so-called storm scenario or high-speed scenario, perhaps a return period of 12 months. So the wind speed chosen was 16 meters per second. And I think the interesting things to look at is when the towers are introduced, they create a downdraft and perhaps a lot more high-speed winds in their vicinity, whereas other options perform differently. And things can be inferred. Let's say, for example, we have parks here. So how is the wind performance in these parks or in outdoor spaces? If, let's say, this tower has plans for some outdoor seating or restaurant activities, then we would want to put up some mitigation measures in here. And in general, we can say, let's say this is the behavior of putting a tower next to another adjacent block. So what if we isolate it differently or have some other massing arrangement? So because of the speed of simulations, we could move things around and actually interpret the movement of massings and how the results are affected. Similarly, for wind comfort analysis, we could do an overall KPI, but it's not necessarily representative of the performance. of the overall project, because maybe in certain areas we want to have certain type of activities. So we want to look at localized wind comfort. But again, we get a very good picture of how the different options perform. If courtyard spaces are more crucial for us for the development, and they have to be necessarily have low wind comfort, high wind comfort and low risk of uncomfortable winds, then we could perhaps focus on just those areas and develop KPIs for those areas. We could choose, let's say, just the parks if they are important, and make sure the parks have less uncomfortable wind speeds throughout the year. Similarly, the solar insolation on facade. So we wanted to bring in the energy factor as well in the project or in the analysis. So we coupled it with Ladybug tools. We just did a very coarse grid analysis on the facades. And that is in some way representative of what's the heat gain from the facades inside the massing. So all the options, we could find out what's the average heat gain per meter square, and that could be one of the KPIs as well. And of course, if we had more time, we would have wanted to split it in different seasons. So in summers, we want to minimize radiation, and in winters, we want to maximize the radiation, and that directly relates to your energy consumption as well for heating and cooling. And similarly, since we are doing radiation, we could also analyze, let's say, the PV potential of this development. So if we say use 80% of the roof area for photovoltaics, what would be the overall PV yield annually? So the numbers here are in megawatt hours. I think we are not going too much into the numbers, but just trying to explore what all is possible if we increase the speed of simulations. So we had 5 design options. We did a few different analysis in 2 days time, perhaps much less, because each one of us was spending just a few hours out of our daily schedules and trying to bring scripts together and then put everything together in just one single package. And I think the key question that we were always thinking, or that made us think in this workshop, is that what if our simulations reduced by the simulation times reduced by a factor of 10 or 100 or 1,000 in case of CFD simulations? So what if we had more time? So I'm a building performance simulation guy. So for me, the first thing is, if I could do CFD results in 10 seconds, I would probably redo the whole approach to outdoor thermal comfort analysis. And as we know, the CFD part is the most time-consuming part. And because InFraReD, let's say, allows us to do one wind direction in 10 seconds, we could do 16 wind directions. And then suddenly we have a base result for all 16 wind directions. And then we could just extrapolate based on the hourly wind direction and incoming wind velocities for the whole year, and get actually the hourly wind values for every single analysis point. And similarly, the mean radiant temperature could be from Energy Plus or IES simulations, or we could just use the incident solar radiation just for the simplified study. And the other factors would be determined, you know this all well. So the activity would determine what's the MET value, the flow value, and then the hourly dry bulb and relative humidity. And then we could literally come up with an hourly thermal comfort analysis for every single analysis point, which I don't think typically is possible in our daily workflows. So yeah, that it just opens up a great new opportunity to further deepen our analysis, and also look at things more not necessarily in a more granular way, but give more well-informed decisions on the usability of different spaces at different times of the year and different times of the day. So yeah, and just want to touch upon the point of quality diversity, as Theodore has mentioned earlier in the workshop. So it's not a matter of finding the best performing option, but just to explore the range of options, which some options might perform good at one thing, some might perform good at some another thing. And if our simulation times increase, we could also have multiple KPIs. It could be outdoor thermal comfort, acoustics, connectivity, footfall. There's just loads of things we can do with the tools that we have at our disposal. So yes, if we had more time, I think everyone can come up with new ideas and new ways of integrating various analysis, and just see the whole diversity of options in their performance and choose what works best for a particular situation. Yep. So that's a quick one. We can revisit any slide if you want. I just went through all of them quickly. Yep.
Brilliant. Thank you very much, Group One. You know, speaking of, if we had more time, that was slightly over. We're going to be, let's be a little bit more stringent with our 7-minute time limit nowadays. But regardless, brilliant, guys. I hand it over to our panelists. Do we have any comments there?
Open up like this for a better look. Yeah.
Emanuele, hi. Do you want to start, or shall I?
Okay, I can start and then leave the word to Giovanni. I'll be brief. So first of all, congratulations. It's amazing what you could come up with in just 2 days. It means that the InFraReD platform allows that, and it's something not seen in previous years. I found very interesting your approach. And I was wondering if I have a question for you, or perhaps a comment, last question. That would be about, I see that in the process of developing this design iteration or configurations, there is an interesting design that try to balance the form of building and the form of nature. So the green infrastructure and the building blocks displacement changes. And then you have used a set of key performance indicators that are mainly related to, let's say, the built part, or the buildings substantially. And reflecting on the state of the art of tools, I wonder if there is space for more evolution of key performance indicators, perhaps as a sub-evolution of the one that you're using, that assess the quality of this formal relation between the build and nature. Yeah, thank you for the supporting image. In a way, today Ladybug's calculation tools do not allow yet to understand, for instance, how a certain shape of vegetation, of the type of vegetation, will affect the climate, as well as this will interact with energy consumption of building and so on. So perhaps I wonder if also the InFraReD tooling is looking at integrate more variable related to the green infrastructure in a way. Yeah, that's my comment.
Yeah, I don't know if somebody wants to answer to that, or I can go on. Also, for the interest of time, because I say that InFraReD is a good timekeeper. So now again, I will congratulate you, and of course half of the congratulation goes to all the work that Theodoros and the InFraReD team and everybody else has been doing in supporting you guys. Because when you see students that I'm sure you guys have prior knowledge in the field, but sort of managed to sort of get acquainted with a new tool and produce so many results early on. I think in 2 days, that's always quite impressive. And having played a little bit with InFraReD myself, I have to say that's quite an exciting tool. It's something that is going to change a little bit the way we interact with climate analysis and the way we, as designers, can use this tool. And that's kind of where my comment would like to go, because I think in a way the way we use the tool should be different. It should be much more dialogic and much more testing options. And I have to say, you were mentioned at some point quality diversity, and I know that there is a whole part of AI research that deals with that. But in terms of your scheme, and that's of course it's probably a constraint of time, I have to say that you went straight onto saying I have this size of block and this is the basic unit variation, while merely from an architectural point of view, I would actually encourage you to see, I don't really know the site, but what we could see in the plans is that actually it's very interesting because there is a clash of different scales, something that looks much more like an historic small scale fabric up northwest, if I've northeast, if I remember correctly, and then this more industrial, larger scale set of complex. So I think that for me, the interesting thing is that when we have those tools that enable us to do all of those analysis very fast, we should try to think more like architects. And for instance, I was surprised that among your KPIs, there was not something that was mentioning simply what was the fraction of the total area of the plots that was covered, what was the gross floor area, those very basic indicators, and you were focusing on all those other ones, because I think that that's sort of the beauty now. Indicators that used to be complex now actually are as easy to calculate as gross floor area, floor to area ratio, and those things. And so I think it's important not to lose sight of those very basic things, but being able to implement more complex things that are dealt with the same simplicity and with the same sort of speed and reactivity, to be able to really have, I think, I don't know, I'm not particularly a fan of generative design, but I think those tools go in the direction that really is like your design assistant that sort of gives you very quickly feedback that you can react and can be a lot more human driven and a lot more interactive. So I think it would be great to see the design that explores a little bit more on those directions, and trying, I think trying big moves and big variations before you focus on two small things. I think on small little changing details, but I think it's as a first step, and already be getting your head around all of those things and putting it all together. That was very good.
Yeah, we did not dwell much into the architectural space. So some of the teammates are actually architects. I'm an architect by training as well. But because the focus was mostly on testing out different tools and what we can do, which typically we won't do in our normal days. So we didn't go much into the architectural aspect of the design. And of course, as you mentioned it correctly, there are different typologies of urban development in different areas around the site. And if you just go from an architecture point of view, we could do a lot more options as well. But yeah, just to keep things simple and get started on the analysis part, we just fixed on certain typologies and just with very basic simple options.
No, I totally understand. It's more this idea that really trying to, I see those tools as some sort of virtual assistants that sort of give you this continuous feedback, and sort of they free you up in a way from this need that we had so far of really systematizing and planning your analysis, because they take so long, and you know that you need to call.
Absolutely.
And instead it can be a lot more fluid and interactive and playful, the sort of interaction. And that's sort of my recommendation going forward, because I understand this is a project that is going to continue, as somebody was mentioning, a competition or something like that.
Yeah, it's actually a running competition. So if you think of continuing, and I think continuing this would be now very interesting, because I think from the methodology, you made a really good first step of having different design variations. Maybe it could have been a bit more diverse. You have tried different typologies, but now you have like this 5-6 different cases you can compare and analyze, and then start to fuse and mix them up, right? And understand what works, what does not work, and then really come up with a mix. And that would be an iterative process where you also get constant feedback from the simulation tools. And this would be, I guess, a very exciting and process.
Yeah. Perhaps, sorry, I have a very small comments now that we touch, let's say, the overall strategic level. I was wondering why the wind is seen as something harmful in Barcelona, and not as a resource, for instance, for cooling down. And I mean, using I don't know if it was the Beaufort Square or the wind chill factor, I forgot. but perhaps it's good to use the tool understanding what are the if you look, for instance, at your first analysis, it's even from the psychrometric chart, it's clear that wind is a resource for your site. So just be careful in your presentation to use the right index. Perhaps, I don't know if InFraReD is conceived for Vienna climate where wind it's as more harmful. Right now, I'm in Bratislava and there is a strong wind, and I guess Vienna is just 50 kilometers away. But perhaps the type of index that should be calibrated according to the site. Yeah, just a small comment.
Yep, I would agree on that. I'm based in Singapore, and we just need as much wind as possible. Wind is, there's no to wind. It's like, so yes, the context matters a lot, and perhaps the seasons matter as well, especially in the European climate. So in summers you would want more wind. In winters you might want to avoid very high speed winds to avoid chill. So it really depends on the context and time of the year as well.
Thank you very much all for a lively discussion and brilliant work to group 1 there. Really great work. Moving on, group 2, are you guys ready to present?
Hello. So, can you see?
Yeah.
Yes, we
Okay,
can.
great. Okay, so I'm going to present our exploration. It's a kind of individualistic because at the end we started yesterday and we just tried to have a thing, but we had different like time scales, etc. So it's a little bit more simple than the previous thing. The vision. Create comfortable urban courtyards in typical residential complex in Seoul, as one of the team members is from Seoul. So we are here, and this is our site with the main wind coming from west and east southeast. So we see that these buildings are like close to 80 meters high. Our design goal is to create comfortable in-between spaces in between those buildings, towers. The strategy is to provide microclimatic comfort, keeping a similar volume, let's say, of the home massing, and reduce the percentage of uncomfortable zones. The indicators were comfort, speed of wind and sunlight hours, visibility. We implemented also isovists as we thought, but we will not show it, as we thought that it could be interesting in terms of the space quality that is being created. And the different parameters that we changed, we're going to see now. So here I will just iterate. Here we see the original formation of the buildings and how the wind behaves from two different directions, and what InFraReD gives as percentages of uncomfortable rate and comfortable. Then the first leg strategy is changing a little bit, rotating the buildings in order to be streamlined with the wind. And we see that there is a reduction in the uncomfortable rate. Then another strategy was creating a retaining wall, so that again we kind of shape the wind, and the retaining wall is quite high, it's 5 meters, relatively high according to what is there. And then again we see the results from that. Repositioning was about, again, making the towers create a kind of a courtyard and centralizing a bit the in-between space. Then changing the height where there was not a lot of change. Another one was thinking more about how you get the in-between space, so mainly designing the in-between. So it was very simple again. It was like creating a grid and thinking about how the quarters are being positioned in the site, whether they are centralized, decentralized, or create a buffered zone. I just want to say that this, since I personally couldn't use the InFraReD because it was heavy in my computers, I couldn't move. I did that in Grasshopper, and there we see also where the problem is in terms of time. It is much more time consuming. And of course, you need to always create, the indices, they're not coming like, the indicators do not come automatically. So again, here I just want to show that on the top we have what is already there. And then with the grid, it's like a buffer zone and the different like microclimates that are being created, and always checking mostly the open space. Again, like buffer and decentralized, and always keeping the same volume like of the buildings. So these buildings are not anymore 80 meters high, but they're 55. And here, Jay, she helped me with, she could actually make the InFraReD run. So we see these two last iterations in infra, and the indicators of the percentages of the uncomfortable rate in there, and in this scheme where we see the big change among different wind directions. And that's it.
Thank you very much, Christina. And for group 2, do you have any comments from the panelists?
And this is like just the mirror board where you can also see the isovis, and I thought it is quite interesting how, it is not wind speed, this is unlike ours, how close they are. But yeah.
Yeah, thank you. No, I think it's again, congratulations. It's very interesting, I quite enjoy here like all those little experiments that you've been doing and trying to understand, and all those little what if scenarios. And can you explain me as well a little bit? You were saying something that part of the analysis was actually done using some other pipeline.
Yeah,
right.
So the other pipeline, yeah, that was mentioned a little bit at the beginning from Angelos, is the integration to Grasshopper.
But so essentially you were meshing and sending through one of the different plugins to OpenFOAM and then getting the results back.
Yes.
Yeah. No, like
maybe one of the developers can talk.
Yeah. So we developed a plugin for InFraReD, the web platform, so we can communicate directly with the platform through Grasshopper components.
Okay.
So the one way was using the website, and I think group 2 combined both. They used the website, made the project there, did some variations there, but also used the Grasshopper pipeline.
Okay. Yeah.
As well. Yeah.
Which is the one that I've been trying to get for my course from Angelos, but I didn't get. I see. You just
let's not have this right.
Are you checking if I'm saying anything bad about you? No, I'm not. Don't worry.
I'm watching.
I can give you my password.
No, but
Whoa.
That's not best practice.
I will delete your account.
In a live streamed.
No, it wasn't
YouTube live
ready. It
stream.
wasn't ready. We were doing this a few months back, and it wasn't ready.
We tried, really, we tried.
No, it's and actually that for me it's quite interesting, because of course when you're on the InFraReD platform, you have a certain limitation in the geometrical operations that you can do, while of course if you are inside Rhino and Grasshopper, you have this much higher degree of freedom, and you can set up things in a quite different way. And also, like you were talking about the indices that are not there sort of out of the box, but then that actually I would argue is also potentially an asset, because one thing that you need to think about, I think in this case was more relevant than in the previous one, is that of course when you're running a CFD, you should take a larger area than your immediate area of interest, right? So of course, when you are then reporting whatever KPI that might be on an online platform, I think unless there will be an implementation of select an area of interest further down the line, then you may get sort of a lot of results that are not really relevant to your specific test, but they just belong to the context. While then when you have the things inside Grasshopper, well, then all the data, I assume, are there for you to analyze and manipulate and to set up your own very specific question. Because I think that's for me, that's the interesting thing. Again, going back to this new paradigm that essentially this enables, because in the end it's all about the relationship that we have with our tools, and the way we can set really a very specific and precise dialogue with them, and using them as exploration mechanism. I think that's very interesting there.
Yeah, for me, I also like working in Grasshopper. I think it's exactly that allows you to explore, because as designers, I think we really aim for diversity. Sometimes, even looking at courtyards doesn't mean that you don't really care about the overall mean value, but you do care what is happening there in specific times and seasons, probably. And you may even like diversity. So you really want to explore more and more ideas in terms of, especially in what we did, was all about morphology in a very simplistic way, as we started with the towers anyway, and microclimatic effect in the courtyards, very similar to what the guys did in a very nice way before Barcelona.
Yeah, perhaps I'll add a couple of words. It was impressive work, and as said before, it's also quite interesting this open workflow where you can sort of use InFraReD in combination with Grasshopper, and perhaps, as Giovanni is saying, try to formulate even a new type of index. The indexes are sort of keeping evolving. Something have to be created. Some can be project related even. So that's remarkable. One only comment is about the integration of this data. Like you show different plots, and also you have this approach of form making and testing. I was wondering if you were able then to sort of look at the final results and interpret. Was it easy for you to come up to understanding what project it's, let's say, from an environmental point of view, more performative or less performative? Did you feel the need of even come up with a cumulative index, or have you even used any index like UTCI or others that allows you to assess what type of solution it's more performative? You have branched the problems and seen the different size of it. I wonder if there is some sort of synthesis.
So I don't know if Jay wants to answer, but I would say that the short answer is no, we didn't, because of time. And like we finished 1 minute before the presentation just to put them together. But and while we were doing the presentation, we were talking like, so what is what do we come up with that this research so far? But it's very difficult to say because it's quite random. You know,
Okay.
we were trying to do too many things. I think for me personally, the most important thing was learning the tools, having the help of the guys in terms of all the bugs that we had, not many, but you know, just to understand what's wrong, what is the workflow. So I'm sorry, the answer is like, there is no depth into the results at the very end.
Sure. No, thank you so much. I felt also for the previous work, but there are a lot of indicators, KPIs or performance visualization, but perhaps is missing this, you know, you expand the problem and you branch it, but then this convergence and perhaps final insights, which InFraReD offers. I mean, one of the virtue of InFraReD is surely this ability of create a synthesis of a wide population of parameters. So perhaps a step further is to understand how to converge to. It's something that I often find in my students, that they come with different plots, and then there is perhaps this missing critical layer of interpretation, and the digital tools perhaps can also help in this. Yeah, thank you.
One thing I could say just on that, like what I thought I would do next. I mean, first of all, the design should be much better established at the very end, set up with you know, having an idea in our mind, more specific. But then also I would like to specify to see the performance on the courtyards, on specific areas that I care about. Not so much the whole plot, but you know, like really focusing on what is happening there
Sure.
and when. For me, that is important. And also what you mentioned before about more vegetation, like in general, like biophilic design is for me also very interesting thing. But I believe that this setup with InFraReD and the fact that it's not time consuming can really help in associating with other workflows as well.
Yeah, I think on this, I think this is really like the central point. I think that the fact that the simulation is less time consuming doesn't mean that we should be doing more simulation, but we should be able to spend more time in really defining the design and defining a relevant question that then the simulation can help us answer. But I mean, of course, this was very compressed for you guys. So I think it was a week, and it was probably 2 days to get your head around what this thing even is. 2 days sorting out bugs, and 2 days trying to do something. So I guess that's how those workshops usually happen.
Yeah,
One day to do something.
To add to Giovanni, probably to me it will take, with my familiarity and age, it will take me 2 weeks to do what you do in 2 days. And I also like what you said about this sort of site-specific approach, which is actually not always there is this luxury of make new city planning and this sort of agopuncture type of intervention. It's nice to see how being able to tackle and define a certain area, how this has a sort of resonation or effect on other areas. I think it's very interesting, and probably what we can only do in cities, try to understand how it's like this, you know, when your body is damaged, you can have two approaches: the orthopedic one that looks at all the systemic one, or you have this bone settler that just come to a tendon, move it, and sort of fix the whole body because it's a systematic approach. So perhaps InFraReD really allows this type of bone settler approach. Yeah.
I call it acupuncture.
Acupuncture. Okay.
All right. Thank you all. Thank you, Christina, and thank you, group 2. Let's move on to group 3 now. You guys ready?
Yes. So I hope my screen is visible.
Yes.
Yeah. Okay, all right. So hi, everyone. I was part of group 3 for this workshop that we had this past week. And it was obviously based on computational urban analysis and design. But for our group work, we decided to focus on urban analysis of existing structures and cities that are too dense right now and don't have the capital to come up with new infrastructure to cater to different stakeholders in a city. So our approach was to analyze some existing structures and see what happens then. So we decided on recreating the existing structures on a site and then try to take out few buildings, as it was a site that was filled with some of the abandoned factories. So the proposal was to, what if we take away a few buildings and see what kind of open spaces we have, because it's something that is a need right now in a city like Barcelona. So our site was also taken from the competition, and the project site was actually around 29 hectares, but the impact and the study was more about the context, which included some new residential buildings as well. So our vision actually kicked off with the idea of super block that is existing in Barcelona. So what they're doing is they're restricting vehicular movement in few parts around the blocks, and that is actually taken as a site for tactical urbanism, where people are coming up with these very interactive spaces that pedestrian use, and people are reclaiming the streets, and that's the idea that is there. So we try to take a step further from that and use performative urban design to create these open green interactive spaces. So the idea was to identify the potential of the impact of the existing buildings around it and use indicator and analysis like wind speed analysis from InFraReD, but also sunlight hour analysis, because the city is a tropical city and we really need shaded spaces there, but also talk about functionality of that open space. So we don't necessarily need a blank ground, but also we need interaction with the existing buildings, and a bureau's analysis to understand what kind of engagement people might have when they're standing in an open space. So another vision was to maintain the place quality of the area. So what happens a lot of times is that in a new urban project, if we take away everything from the site and introduce entirely something entirely new, a lot of the times it gets ends up being alienated by the people around. So we wanted to avoid that, and obviously explore some possibilities. So and use controls like different configuration of open spaces that we know of to kind of come with 12 different iterations. So this was the existing wind speed analysis of this site. So we focused on the storm scenario and low wind scenario to get an overall idea about the site. So the structure of our iterations was to define 3 types of open spaces. So one is a primary bigger open space that can be central to the entire site. The second typology included secondary spaces that are connected with existing road networks, but are still can still stay within their areas, and then talking about decentralized even smaller spaces all over the site. So these were the different 12 iterations that we decided to test using InFraReD and other simulations. So this is the analysis, wind speed analysis, that we use to generate different KPIs and also to understand the kind of trends that these wind speed analysis were telling us about. So these areas where the structure are actually converging at some point. So that creates some kind of an increase in speed. So understanding that kind of trends was important to identify which works better for that kind of space. And then an example like this would tell us that we can have two different space with different configurations of wind comfort there. And also further, we took in consideration the existing infrastructure and road network, for example. So moving on to what kind of output we were able to get within Grasshopper. So there's much better way to explain all of this, but to focus on what we could extract from the output. So the idea is to first compare along the same type of open spaces and identify which works the best. For example, in the first row, you can see the last one is the least dangerous when it comes to storm scenarios, but and can provide spaces that are best for walking fast, for example. So we can talk about creating jogging parks and stuff like that. And in the second row, we see case 2C was most comfortable, least dangerous, and was also good for creating specific kind of spaces. And the third iteration, the third row shows us that the second case was most comfortable in all of them. So the idea is to compare them first within the group and then use other analysis to compare them with each other in a column. So this is the idea of using visibility angle as input. So one of our ideas was that we can repurpose these existing buildings into mixed use buildings. So lower floors can be commercial areas and the upper can be office spaces or even residential spaces. And then if we have lower visibility angle, we would actually higher visibility angle, we would have higher engagement. So this is the kind of charts we could come up with, that what spaces are able to interact best with the surrounding buildings, so that the business aspect of the area is also maintained and there's a lot of interaction within the people as well as the business owners there. So this is an expected scenario of sunlight hours analysis. So smaller spaces have lower sunlight hours, so which would work best in a place like Barcelona. So this was the best option we could summarize with. So here you can see there are three major open spaces with different space quality as well. So for example, this open area is actually railway tracks, and this is the view from here is very different from what you would experience here, which is near traffic, a very busy road. And this space is kind of have some kind of enclosure to it and a different kind of wind comfort when we go here. And compared to that, when we talk about engagement, so there are three different types of spaces we can talk about here. So there are three. So we have lower engagement, where we can talk about people just spending their time and for leisure activities, and maybe higher engagement areas where businesses can thrive better. And then solar analysis tells us that these are better during the summer areas as well. So further exploration that we were all discussing amongst ourselves was that we could start with cataloging the existing structures, that which can be saved, which cannot be saved. So that can be a part of where we can start. And also one of the ideas was to maintain the total floor space throughout the site. So structures that are much more stable can be expanded or built further, and then we can kind of see a change in our skyline and change in sunlight hours in that open areas as well. And then of course footfall analysis, we did not have time to analyze that deeply, all the iterations, but it's something that we can definitely work on in the future. And one idea was that taking the best option and going back to like for example going through a Rhino CFD workflow and checking how accurate our output was. So my overall experience is based on my work that I had done a while back, but this took me months to actually get to a much complex analysis. And then too, I was able to only get values of all the grids in my area. So this was very tedious for me. So I'm very impressed with what InFraReD was able to accomplish in with this process. So my best takeaway is that it's obviously the quickest simulation that I have worked with. It has easy steps that I could follow, and we can talk about multiple snapshots for a single project. So typical CFD analysis would not allow me to do that. And the best possible outcome that I could get from it as a student, it's so easy and accessible to harness the power of machine learning in such a way. So that's the best takeaway I got from the workshop. And thank you for your attention.
Thank you very much. And thank you for the kind words there as well. Really appreciate that. Panelists.
Thank you. I think this is very interesting because in this case, essentially, you had a very, really nice work. I think in this case, you had this very well-defined problem. Let's say, one could simplify and say, let's use a range of criteria. And of course, if you were to do this in real life, you would add a number of many more criteria. But of course, in the limitations, that's sort of a first step. But you say, well, let's look at as many criteria as possible. Let's use those analysis to essentially understand which one would be the best structures to demolish in this neighborhood to improve the overall quality. What do I take away that gives me the most? I think it's in this case, this would really almost lend itself to some very systematic approach. No, so this could actually, in this case, you've probably done it manually, trying a few things, but this would really you have only a potentially large but finite number of possibilities of combinations in this range, and you could define all of your parameters and sort of run a large multi-parameter analysis and sort of come up with what would be the end state that would be closer to what you're doing. So in this case, I think it's interesting because it's compared to what we were trying to hint at before, this sort of this relationship with the tool, sort of like an assistant or a partner that sort of guides you as you create a design. In this case, where you're actually destroying an existing design, it's a different approach where you could actually just sort of brute force through it and just take advantage of the fact that you can actually do this time-wise. So I think it's interesting for me because I think that a lot of what we need to understand with this tool, that there are different things. There is, of course, all the technical development and all the kinks and all the things that are not quite as precise as you would like them to be. But I think that the real interesting thing beyond specifically InFraReD, but with all those AI tools and how they is really how they can change the way we interact with our design process. And I think for me, it's interesting to see those different scenarios and those different user cases and how it can be more creative, how it can be more analytic, or in this case, literally destructive, and how you go around that. So no, thanks. It was a very interesting test, let's say.
Yeah, thank you. I agree with Giovanni's comments. I have not much to add, but perhaps also it's interesting to design using a sort of a shaping of the outdoor as a departure point. Generally, we design almost the building, and then especially in city, the public space is a consequence of that process. But for instance, by playing with the visibility angle, that allows to reverse sort of the process. So it's an analysis or a making of playing sort basically with the void, and especially with the issue of climate change, especially with this need of spending more time on the outdoors. Perhaps the outlook is to design spaces starting from the outdoor rather than the outdoor. So on that light, it's really interesting. So congratulations again on this group work. Yeah.
Thank you.
Brilliant. Thank you much all. Thank you, group 3. Now for our final presentation, group 4, I noticed in your Slack you're raring to go. Let's have it.
Sorry, I'm still muted. So can you see it?
Yeah.
Can you quickly confirm? Okay, cool. So hi everyone, this is group 4. So we didn't focus much on the design. It was more for us important to explore the tool and the analytical part of what is actually possible and the scope of it. So we choose the site of the Nordwestbahnhof in Vienna. It's an abandoned train station, and objectives for us, it was to kind of an early stage proposal to come up with the analysis which leads to different typologies and how they perform in space, and also considering the network optimization, and also with the building typologies, the embodied carbon emission, which we'll show you later. A first attempt to just get to know the site a bit and the climatic condition, mainly the wind rose, the wind coming from southeast and northwest, and then the sun path. A first baseline from InFraReD, basically showing all those different metrics and how we can, this gives us a first idea of where we can put our typologies, how they perform, and later on how they iterate. Noor? Sorry. I go on.
Yeah, okay.
Go on.
Okay, so our side, it was like an old train station. So we wanted to choose this side because it's close to the river, and also it has like green areas, and also you can see here like voids. So that's why we wanted to see the effects of the wind is coming from southeast, like the strong wind. Because here, as you can see, we can like, there is nothing. So the strong wind effect will be like, they will feel the effects more than the other zones. So this is the green areas also, and these are the voids. We can go to the other slide. Yeah. So at the end, we decided to focus on zones rather than focusing to whole site, because, you know, we just had 2 days. So we just wanted to start focusing on zone 1, because like it's surrounded by residential area and also with voids and green areas. And also we can see the effects of southeast strong wind. So that's why we started to analyze zone 1 and proposed a design to this area. Yeah, this is the close up. Yeah, you can take over.
Here you go.
So here we just did some quick, because even inside the zone, the 500 by 500, we thought that was really big. There's a lot of areas for us to use. So here we just did some quick terrain analysis and run some water simulations to see what are the areas with high probability for the water to accumulate. And we select those regions as also green areas. The objective here on the flow, on the workflow, was actually to see the relationship of those green areas in relationship to the other green areas that already exist, and probably also try to measure that using the network tool that also already exists in terms of distance and centralities. but we encountered some problems making the network analysis to work. But the idea was to, in this early stage already, understand the network, understand the environment in order to then start creating the areas for the topologies.
Yeah, so a quick site vision, a summary with overlaid analysis. Our goal is to have a higher street density, higher accessibility to especially the zone 1, and where we can integrate more shaded space, more green space, and also according to the flooding analysis, the pond location. So first, coming from the vision, what I actually already told you, going through the strategy, including high visibility analysis, walkability, and then building new typologies to minimize embodied carbon and also improve outdoor comfort. So these are the metrics we used, which I will run through quickly, the indicator and then the optimized version on the bottom, basically, with all the improvements, basically. A first baseline of the visibility analysis is with a radius of 600 meters to evaluate the site, kind of imitating a walk of one person going along the site. For each zone, we focus now on zone 1 for the network integration, which is first on the left, the current closeness centrality, which means kind of red is reachable within 10 minutes. And in the target one, what happens if we kind of change the network and we break out those kind of patches on the site. Same with betweenness centrality, which means kind of going from most likeliness to pass through the streak segment. And then if we change the network on the right, it increases the likeliness that people kind of walk through. Antigone.
Yeah, and so following that, we wanted to have a look on what's happening on the inside of the new buildings that we're trying to propose here to improve the environment. So we use the BOM plugin for that, and we constrain embodied carbon analysis, let's say, in the production state. So emissions coming from the manufacturing, A1 to A3, and then the IC database. And we only checked from the scope of the building columns and beams, just to keep it short. Yeah, we considered concrete and rebar for this study to proceed. If you go to the next slide. So for the CFD scenario, we said, let's think of the two wind directions that are the most prevalent ones, so southeast and northwest, and then let's see how can we improve the percentage of comfort for people, so for wind comfort actually during a windy day. So the percentage of comfortable hubs that people can sit for a long or shorter time. So we focused on kind of these regions. And then, yeah, so we started with the baseline, trying to evaluate this. We put the range up to 8 meters per second, as we said. So we are looking on the lower side, how can we increase this comfort? And then on the next scenario, you can see the indicators like how we increase, let's say, the percentage by putting some building volumes, but at the same time trying to keep the embodied carbon, tracking down the embodied carbon actually, and the building gross floor area for square meter tracking. And so if we try to investigate different typologies, like a more high-rise building, a more like wagon-style buildings, what is the impact? There are small changes in that. So if you proceed in the next, we try to kind of move them, see how we can increase a bit the comfort percentages of our floor of our site for people sitting comfortably, and then if we omit some buildings and put some trees instead,
can we keep the same percentage of comfort? Then the carbon here, I think it's a glitch, so it doesn't, it keeps the same carbon. I think it's something wrong with the script, my script. But yeah, the idea was to kind of test different building typologies and vegetation and how this interacts with carbon and comfort, wind comfort. So in the end, we tried to start putting everything together, like visibility study, the solar studies, the wind comfort, the embodied carbon, trying to see where everything sits. And in the last slide, we said, okay, let's start from the baseline, and then based on the conditions we have, let's select what fulfills also, for example, omitting some buildings, putting some vegetation in the places where the water accumulates as well. So we can create some comfortable hubs, because this takes into account only wind comfort. If we talk about outer thermal comfort, more things come into place. And then visibility is another thing that could be connected to the buildings. Where we put the buildings, we obscure views. So this would come next, but yeah, feel free guys to jump in on final concluding remarks. But in general, I think the InFraReD context enabled a lot of integration and also a lot of iterations as far as I'm concerned. Like usually when you do an analysis, you usually set up everything and then you hope to get the results you want. And after this, if you are to do again an elaborate analysis, you are kind of cautious about the fee and what this means to the time you need to consume. So I think this enables to get a glimpse. Also for people like me, I'm getting a CFD introduction at the moment, going deeper into that. And so I haven't been so much familiar with that, but I could make sense of this kind of indicators. So yeah, everyone.
Thank you.
Thank you very much, guys. Panelists.
Thanks.
Yeah, perhaps I can just say something, if that's okay. So congratulations on what you achieved. It's really nice, this selection of key performance or indexes belonging to different families of indicators. That's quite remarkable. And this is also very much related to the nature of city problems that are climatic, which are about resources, which are about well-being. And also it testifies, or it's a wisdom that each city has a different set of problems. So it's very important that the tools that we use are flexible and we are able to change, let's say, type of solution and type of material, for instance. So perhaps this is also a line of direction for development of tools. For instance, in your embodied calculation, you have thought about concrete. And if I'm not wrong, the context is Vienna, where perhaps you have a large availability of wood. Given the context, I think Trump even said that Vienna is, there are buildings in between the forest rather than have some green space in between buildings. So, it would be interesting. I think it's an absolute stunning frame, and probably a line of the expansion is to enlarge the options. Perhaps once we build in wood, which is by nature carbon positive, perhaps we can see that this is a minor issue, and perhaps we can focus more on the climatic feature of the site or the well-being of. So it's very interesting because by using this larger frame, we may even not focus on one issue at all because it's not an issue. And perhaps the question is, at the end of this multifactorial process, which of the four issues it's the prevailing one? Yeah, that's the question. Which you found as, if you would now begin the design, which issue would be the more critical one within this context, after all this set of analysis and this nice chart that put them in comparison? Yeah.
I think it's, I can quickly share again. It was also kind of difficult to elaborate more on, for instance, if we kind of take all the measures together, you could see the sum in a certain, so these are the 4 iterations basically. So you can see in the second round of iteration, we have a better performance of one factor, and on the third one, we have a better performance of another factor. So it's kind of, it was more about to kind of consider all together and get the balance, and maybe more also look closely to Vienna as a site, and then think, okay, if in this climate, sun studies won't be that dramatic to consider, whereas it would be probably in the south or the Mediterranean area. So maybe wind is a more dominant factor. So I think with those factors, seeing, making more research into the actual site, this will probably help us to lead into taking one factor as kind of the dominant one.
Sure. So you're saying this is a very powerful tool to then engage with the different stakeholders and understand what we can prioritize, but having a clear vision of what are the consequences of design. Okay, thank you so much.
Yeah.
No, thank you. I really enjoyed this presentation. I think I have to agree with Emanuele. I mean, it was very nice to see the breadth of the scope of your analysis, but also how it seemed everything was really quite logically tied together into a basic vision of how can we, or what should we try to achieve in recomposing this sort of fragmented or broken, let's say, part of the urban fabric. So I thought it was really interesting. I think that the slide, there was a slide that was showing all a series of overlays with the site and the site vision, which I thought was really powerful, because in that one, essentially, you were setting very specifically. You had I don't know, you had a bunch of dots saying that here we want more shade, here we want more green, here that's where we should have grass, water ponds, here that's where we should add more density. So it's sort of like really I think that exactly. I think that's really like sort of having this blueprint as to what you would like to achieve, and this sort of your design hypothesis, and then you have all those analysis tools that it's InFraReD, but everything else as well, that enable you to then refine and verify how can you achieve this design intent. So I think this one for me was a bit what was setting slightly apart your work from the rest, because I think you started with a very clear design intent, and that makes all the subsequent exploration a lot more focused. And I think then of course when it's a more focused conversation, it also gets quite interesting, and we can start seeing that even in the very limited amount of time. So I think it's very interesting. I think it's interesting also the fact that we start thinking about embodied carbon. I mean, like the question there. I mean, I understand. Of course, if you do it different materials, you have different performance. I think it makes sense to sort of say, well, we're going to build with one material and we're going to compare the options there, because otherwise it's and what was there an intelligence saying that if I build more stories, I don't know, the lower floors get a bigger columns, and that's why there is more carbon intensity, or they need to get a better foundation?
This is
just
the
out of
next
curiosity.
step. This is the next step. No, it was very simplified, just similar slabs and the columns, no changes, but only the keeping track of the area floor.
But I mean, to me, this is the sort of fascinating thing about these the overall direction of analysis that sort of things like InFraReD point towards now, because ideally you don't need to be a structural engineer doing all the calculations of what is the diameter of a column if it has to hold 20 floors above,
yeah, but you need
the foundations. Yeah, no, but you can just connect to an API. In the past was call an engineer and wait for a week. They comes back with something, or just he pulls something out of his head just because maybe he has 20, 30 years of experience. I can tell you more or less what that is. But now in the future, it's going to be just call an API through whatever interface you're designing in and get all these sophisticated analysis already built in. So I think that's really the interesting direction that this InFraReD points to, beyond just environmental analysis and making CFD faster. It's really, there is a whole world of AI-powered tools that just wait to be developed and that enable essentially to formalize the knowledge that so far is dispersed into consultants into something that is more readily accessible. So, but anyway, that was a bit of an aside, but I think it was a really interesting work to see all those different metrics coming together, but within a rather coherent framework, because you had quite clear what you were trying to achieve.
I want to say something on what Giovanni just said, because I feel like I told you a couple of times during the workshop that you may not understand, like, well, you know, how easy it is, like, to run a CFD analysis, and then if you had to do that in the past, you probably understand a little bit better. And now Giovanni is saying all of that, so, like, you know, you have to call an engineer. He was actually the engineer that people would call from, you know, when we were at Foster's working together, people would call him and he'd, like, you know, have to tell them to wait for a week now. And
I was the fast one. Come on.
Yeah, you were the fast one, but it doesn't matter. But you were still like depending on the tools. So I feel like we are like the grandparents, like, talking to the kids about, like, you know, how they don't understand how difficult it was to pick up the phone and, like, dial the numbers in the past, and now they can just, like, FaceTime or something. So it's I hope we don't sound like that. But yeah, I think that I totally agree. Yeah, Nari doesn't even know what a phone is. You're too young, mate. But yeah, this thing that used to do, like, that thing. Anyway, so I think that what Giovanni was just saying is, like, I think really important, like, because I think that's where we're heading, and we're really happy to have you working with our sort of, like, at least attempt to do that. I'm just gonna shut up now and let Nari sort of, like, close the round. Thank you, Giovanni and Emanuele, so much for your time. I don't know if anyone else wants to add anything, or
I would just like to add, I think that I really liked the first part of your project where you did use all the analytical tools and analyze the site, and then actually informed your strategy and further design actions upon this analysis. So you really took kind of a step further to use the results and KPIs you got to inform your further steps. I think that was really great to see.
I would like to add a comment. I would like to add a comment on that, actually, because Emanuele was talking about understanding the context, and I fully agree. And in the end of this workshop, like, getting, you know, to this Friday, I think that in my perception, the powerful of what we are seeing here, it's actually because nobody in this group, for example, ever visit Vienna. We don't know Vienna. We have no idea, like, how to arrive in Vienna unless we buy a ticket on the internet, on the airplane, and get there. And this tool actually allowed us to see that part of Vienna, you know, that understand the context, because we were playing with the building, we were playing with the site, and it gets familiarized with that context. And so I think the presentation, in a way, it looked a little messy in a way, also because everybody here in this group has a job to do during the week, and everybody was kind of busy, but and everybody tried to bring out their own knowledge into to add this into this project. but for me, it was first fascinating that we could use CFD as an early stage analysis. And this is the first thing. We are now considering, the CFD just as a terrain analysis, like something that in the past we were not. But for me, on top of that, for me, was actually that I got to be more familiar with the context, and I got to understand the site, and I never visit there. So that for me was what I extract, the value that I extracted the most from this tool. Because, for example, I think we can run a lot of different simulations. Like we got to a point, for example, it would be nice to do a pedestrian path that goes under a building, and then on the side, and then okay. So do we think maybe we can trust on that CFD analysis to do like a tunnel simulation to see if that's going to work? Honestly, I don't know if the tool is still powerful today, to do this kind of analysis. But that is like all the way in the end of the design approach, But so for me, it was really interesting to see how powerful it is in the initial analysis, and how it in the most part of the initial analysis is actually to help me be more familiarized with the context. So for that, I would like to say just thank you for the team who is pushing this, and I think that this will inform and help people more than you think. Because sorry, I talk too much. If I'm talk too much, you guys can just cut me, okay? I work in some projects in Africa, for example, that the only kind of information we had was Google Earth satellite images, And now, like, if we have just some open data about the wind, we can actually have a CFD analysis of the site. So it's I'm excited about this kind of development, especially like how intelligent people are using artificial intelligence also, because for me, this is exactly the purpose of how, fast calculation and like AI. So this is, I don't know if that was a good moment for feedback. Thank you.
It was
very much.
Yeah. So I'd like to say thank you to Giovanni and Emanuele. Narid, do you want to share a couple of words before we close the...
Nothing beyond brilliant work, Group 4, and brilliant work to all the groups. You guys exceeded expectations. Really cool.
Just wanted to thank you, Angelos, Theodore, Narid, Sirosha, and Giovanni, that finally I meet on a camera. And thank you so much. It's always I always learn when I participate in your events. Thank you so much.
It's always great to have you, Manuel. Like, and you're always welcome, and thank you for taking again the time to help us sort of like understand the project better. And yeah. Giovanni as well.
Likewise, it's always fun to see what you guys are up to. Is always a great learning opportunity, and it's good because you give some comments, but you go away with so many more thoughts and ideas, and it's always refreshing. Thanks. And great work to all the students.
Big applause to the students.